Hello students, are we all here now? Okay, so just to ensure that all of us are here and which all centers are today with us, please let me know how you all are doing today in the chat box. Okay, we have Itanagar joining us. Do we have any more center with us? Okay, Senapati Center, good afternoon. Shillong Center, okay, I think some of the students in Shillong Center aren't back yet. We'll just revise quickly for 3-4 minutes and I hope everybody is back to the time we start with the new concepts. Okay, so Senapati, Shillong, Itanagar, we have all of you. If there's any more centers, please let us know. So, what do you remember from yesterday? What did we study? You can just give me names of some 1 or 2 reactions, and I think we also studied one very important name reaction yesterday. So quickly let me know what did we study yesterday or what do you remember from it in the chat box. Okay, yes, we studied the preparation of benzophenone yesterday. Good, Itanagar Center. We studied Fidelcraft acylation. Great, Shillong students. Okay, so it seems you remember a good deal about what we studied yesterday, which is great. So we will just quickly do a couple of small questions just to ensure that we remember what we studied till now, and then we will move ahead. Okay, let us continue our studies. I hope all the students of Shillong centers are back now. And if any more centers join us, please let me know in the chat box. So in the first question, you are supposed to write down the structures of the products formed in the given reactions. Okay, and this time you are supposed to give me the name of the product form as well as the structure. Okay, just to ensure that you're not making any mistake anywhere. In all of the previous questions, I remember I only asked for the name, but this time you're supposed to give me both. Okay, as far as structure is concerned, you can just write it down something like this in the chat box. Okay, that should work. Okay, so in the first question, you have benzene reacting with Shillong students, are all of you back now? Okay students, start solving the first and the second part and let me know both the name of the compound as well as the structure of the compound which are formed in both the cases. Okay, Senapati students, great. You're given the correct name of the compound, but please also tell me what is the structure or the formula of the compound. Also, how many students are present in Senapati Center today? Okay, what is your name? The student present in Senapati Center? Okay, so since you're just one, I'll call you by your name rather than your center. It's Savio, right? I hope I'm pronouncing it right. Shillong students, are we solving this question? Itanagar students as well. How many students are present in the Itanagar Center today? Okay, what is your name? Itanagar student. Shillong students, I haven't received any answer from you yet. And I can see some of you talking, constantly talking. For all the students who have just joined us, you are supposed to give me the name and formula of the compound of the product which will be formed in both of these cases. Okay? Until now I have only received right answer from Xavier from Senapati. I want answer from both of you, from all of you. And Xavier, please also try solving the second part. Okay, Shillong, great. The Menglong Center, good afternoon. Please start solving these questions now. Students, we did both of these yesterday itself. I should have received an answer from all of you by now. I hope the internet is working fine. Shillong students, what is the answer for the second part? Same goes for Savio and Itanagar Center. So most of you have given the right answer for the first part. We basically have Friedel-Crafts acylation taking place here. And so the product formed is, you have a benzene ring and you have C2H5 attached to it. And the side product is HCl. Okay, the name of this product is propiophenol. Shillong Centers, your answer for this name of the compound is also correct. Okay, 1-phenyl propanone is also correct. Temenglong Center, great, correct answer for the first one. And great, Temenglong, your second answer is also correct. Students, I am waiting for answer for the second one now. Okay, Senapati Center, great, correct answer for the second one. Students who have done the second one can start attempting the third one. Shillong, I'm not receiving an answer from you. I hope it's because of the internet issue and you're able to solve the problem at least. Same is with Itanagar. I haven't received an answer or any news from you from a while. Shillong Center, I think your internet should be working now. Can we have the answer for the second one? Temenglong Center and Itanagar Center, can we have answer for the third one? Same for Senapati Center. Just to give you a hint, we studied the third reaction in I think the first class, and you will have tautomerism taking place in this one. Okay, Senapati, you gave the answer as propanol, but please check once again. Okay, Shillong, correct answer for the third one. Shillong, I haven't received the answer for the second one from you. I hope you're able to solve that as well. Okay, Itanagar, correct answer for the third one. So most of you were also able to solve the second part except Shillong. The answer for this one is, so this reaction will take place in presence of dry ether, and you will get two moles of 1 phenyl propane 2 on. Okay, all the students who had doubt in this one, you can note this down. And now we are looking for the answer for the third one. Okay, Senapati Center has also answered, great. So the answer for the third one would be, so in this reaction mixture, first you will have an intermediate product forming, and then this product will undergo tautomerism to give us CH3 COCH3, okay, which is acetone or propanol. So students, both the answers acetone and propanol are correct. Okay, Temenglong, you said prop 1E. Please just cross check it once again. The answer is propanol. Okay, you won't have an alkene forming, but a ketone here. Okay. So I hope this is clear to everybody now. If anybody of you has any doubt, you can let me know. Otherwise, we are going to continue. Okay. So in the last class, in the last few classes, we have studied the basic properties of aldehydes and ketones. We also studied the preparation methods for aldehydes only, then ketones only, and for both aldehydes and ketones. Okay, today we are going to start studying about the physical properties of aldehydes and ketones. If at any stage you have any doubt in what we are studying, you can always let me know in the comment box. Shillong students, I can also see you, so you can also raise your hand. Okay, so in physical properties of aldehydes and ketones, the first one that we are going to study is boiling point. Okay, you must have studied boiling point as a physical property in your earlier chapters as well for alcohols, phenols, ethers, etc. For any chemical compound that we have, there are some fixed physical properties that you are going to study. First will be the boiling point, second would be the smell, the third would be the solubility. Okay, these are some of the basic physical properties that you should know for all the functional groups that you have in your syllabus. So now you've already studied the boiling point of alcohols, phenols and ethers and also hydrocarbons. Aldehydes and ketones actually have their boiling point greater than that of hydrocarbons, and this is because aldehydes and ketones have a polar carbonyl group. Okay, you have already seen that in the C double bond O group, oxygen is more electronegative here. So therefore, it tries to attract the shared pair of electrons towards itself, due to which this develops a partial negative charge and our carbon develops a partial positive charge. Okay, and this leads to the polar carbonyl group, and because of this we see weak intermolecular association due to dipole-dipole interaction as well. And how this can be represented is, let's say we have C double bond O, this will have partial negative, this would have partial positive, and this would be attracted to our carbon, which is the partially positive. Similarly, the oxygen of this one would be attracted to the positive carbon of the second one, and so on. Okay, so this is how we represent intermolecular dipole-dipole interactions. Okay, and due to these dipole-dipole interactions, the boiling point of aldehydes and ketones is slightly greater than that of hydrocarbons of comparable molecular mass and size. Okay, so this is the first comparison point that we have learned. Is this clear to everybody? I'm freezing this for 1 quick minute so you can note this down and then we will move further. Okay, students, assuming all of you have noted this down. Now, if we have to compare the boiling points of aldehydes and ketones with alcohols, then we see, you must have already studied, that alcohols have hydrogen bonding between them. And hydrogen bonding is the strongest type of bonding, and therefore, the boiling point of alcohols is actually greater than that of aldehydes and ketones. Okay, so this is the comparison chain that we have formed till now. Aldehydes and ketones have greater boiling point than hydrocarbons, and alcohols has greater boiling point than aldehydes and ketones as well. Okay, and if we have to represent the hydrogen bonding between alcohols, it can be done in the similar manner. Let's say you have this is the alcohol that you have. Okay, this is a OH group of the alcohol. This will have partial negative charge and carbon and hydrogen would have partial positive charge. Okay, O is electronegative and carbon and hydrogen both are electropositive. So our oxygen will try to attract electrons from both the sides. Similarly, even in water you would have partial positive and negative charge forming up. And this continues. Okay, so this is how we represent hydrogen bonding in alcohols. Now, we studied this, okay, we compared alcohols, aldehydes, ketones and hydrocarbons. But now if I have to talk more about aldehydes and ketones, which one of these do you think will have higher boiling point? Okay, students, I am waiting for an answer from you in the chat box. Which out of aldehydes and ketones do you think will have a higher boiling point? Also, if you know, you can let me know the reason also in the chat box. And it's okay if you don't, we will discuss it soon. Shillong, Temenglong, Senapati, Itanagar centers. Which out of aldehydes and ketones do you think will have higher boiling point and why? Okay, great. Senapati student says ketone. Itanagar says aldehyde because they are more reactive. Okay. Both good arguments. Shillong and Temenglong students, what do you think? We have 1 vote each for aldehyde and ketone as of now. Okay, it seems we have a divided audience on this one. The answer is actually ketones. Ketones are found to have slightly higher boiling point than aldehydes because of more polar nature. Okay, ketones have a higher boiling point, only slightly higher than aldehydes because of more polar nature. And why this happens is because you see that your ketone has two electron donating groups. Okay, it has this and it has this, which means your oxygen is going to get electrons from both the sides. So it will have slightly more partial negative charge. Because of this, it will be more strongly attracted to your other carbon group. Okay, in this interaction that we drew just now, in this one, if your oxygen has more of negative charge, it will be able to attract both of these groups more strongly together, and due to this you will have to provide more energy to them so that they boil, and therefore they will have higher boiling point. Okay, is this clear to everybody now? Please let me know in the chat box if everybody is clear about this or not. So the order that we have formed for boiling point is hydrocarbons, the lowest boiling point, then you have aldehydes, then you have ketones, and then you will have alcohols. Okay? However, please note that this comparison is valid if we are taking compounds of similar molecular mass. Okay? You can't take a hydrocarbon of mass, let's say 100, and an aldehyde of mass 10 and then compare them. Okay? You always compare together substances of similar molecular mass and similar structure. Okay? Because when things like molecular mass, branching, etc. come into the picture, the boiling point values become more complicated, as you must have studied in your chapter alcohols, phenols and ethers. Okay? Does anybody have any doubt in this? Itanagar, Senapati Center, Temenglong Center, are all of us on the same page till now? Okay, all of you seem to be clear with this up till now. Now we are going to study solubility. Okay, what we have studied is that lower aldehydes and ketones, which is up to let's say which has carbon atoms 5, up to 5 carbon atoms are soluble in water. However, as the molecular mass and the number of carbon atoms increase, our aldehydes and ketones start becoming less and less soluble in water. Okay, and the solubility is again arising from polar bonds which are formed. Okay, we drew this a while ago also, the structure, the polar bond formation between aldehydes and ketones and water to show the solubility in water can be drawn in such a manner. Okay, this hydrogen bonding is what helps dissolve ketones and aldehydes in water. Similarly, if you have to compare the aromatic aldehydes and ketones, you find that they have low solubility. Why? Because they have the benzene ring in them, which is very bulky. Okay, our water or actually any solvent is not able to dissolve this benzene ring that well, and therefore aromatic ketones and aldehydes have lower solubility compared to the aliphatic ones. One more thing to note here is, you must have studied it, and if not, you should write now that like dissolves like. Have you studied this ever? This is actually a phrase which we use in chemistry very often. It is a very famous one, like dissolves like, which means similar substances dissolve in similar ones. Okay, this means that if I have any organic substance, it will dissolve more better in an organic solvent. Similarly, if I have any polar substance, it will dissolve to a good extent in a polar solvent rather than a organic one. Okay. So, because of this only, we find that our aldehydes and ketones, even the aromatic ones, are very well soluble in organic solvents rather than water. Or water is a polar solvent. So, therefore, aldehydes and ketones are soluble only to some extent in them. However, they are very well soluble in organic solvents. This is actually very important because if you tend to pursue chemistry in your higher classes or in your undergraduate, you will see this is a very important concept for practical chemistry as well. Whenever you are dealing with any compound like alcohol, phenol, aldehyde, ketone, amine or anything, and you want to want a reaction to happen with it, your solubility is what will decide what solvent you should use in your reaction mixture. Okay, so this like dissolves like is a very important concept which you should always remember. This will help you decide a lot of solubilities. Are we all clear till this point? Okay, great. So, moving ahead, this is a very easy topic today actually, comparatively easy topic that we are studying today. So, the next physical property that we should study for aldehydes and ketones is their smell. Okay, this is one of the properties which also helps us decide which substance do we have do we have in qualitative analysis? Okay, you might have salt analysis as one of your practicals in your school. So smell is actually a very important factor also. You see that the lower aldehydes like HCHO, CH3CHO, etc., they have a very pungent or unpleasant odor. Okay, they will have a very sharp, bad smell. If you happen to go in any chemistry lab and you smell, let's say, HCHO once, you will be able to recognize its smell. It has a very sharp, bad smell. Similarly, for aromatic as well, benzaldehyde, for example, also has a very bitter smell. Okay, however, if you go up to higher aldehydes and ketones, which means that to increase the number of carbon atoms, you will see that they start having a very fragrant smell, or they start having a fragrance. Okay, so this is one of the physical properties that changes in aldehydes and ketones as you change their size. The smaller aldehydes and ketones with less number of carbon atoms have a very sharp, pungent or a bad, unpleasant odor. However, if you go up to higher aldehydes and ketones, you will see that they have a very nice fragrance. In fact, if you remember, we also studied in the beginning of this chapter, some of the aldehydes and ketones which have a nice smell are cinnamaldehyde. Okay, cinnamaldehyde is actually related to cinnamon, and cinnamon, if you remember, is used in a lot of food items. Cinnamon is basically dal chini, what we call in Hindi. If you know, there is a cinnamon tea as well. Okay, you all must be knowing it. Cinnamon tea, it has a very nice smell. Similarly, you have vanillin. Vanillin is basically related to vanilla. Vanilla also has a very sharp, nice smell. It is used as a fragrance or an essence in many of the food items as well. Okay, like we add it in cakes, we also use it in a lot of non-food items like making soaps, perfumes, shower gels, etc. Some of the ketones similarly are also used in perfumes. Okay, students, is this clear to everybody? These were comparatively easy concepts that we studied. You all are a smart batch of students, so you should be able to understand all of them. Okay, great. Shillong students, Tamenglong students, Senapati student, are we all on the same page? Do you want me to repeat anything that we have studied till now? Shillong students, is your internet working now? Are you all clear with this? Tamenglong students, I haven't heard from you in a while. Okay, great. Tamenglong students are also on the same page. I hope Senapati Center student, I think Savio, you are also understanding this. Okay, great. So all of you seem to be understanding this. So we are going to take a quick 5-10 minutes break, and after we come, we are going to solve some questions based on what we have studied till now, and then we are going to continue our topic. Okay, so quickly take a small break, refresh, drink water, walk around, and then we will solve some problems. Hello students, is everybody back from the break now? Okay, students, do you have any doubt in whatever we have studied in the first half of the class? Students, any doubt? Or should we move ahead? Okay, great. It seems. Okay, we have Shillong Center with us. Okay, I think some students have doubt in dipole-dipole interaction, so I am going to quickly revise that once and then we will move ahead. Okay, so in the case of aldehydes and ketones, we have C double bond O. Okay. Just give me a minute, students. Okay, students, sorry for the technical problem. So I was explaining you dipole-dipole interactions. So in the case of aldehydes and ketones, you know that we have C double bond O. Okay. So now we know that O is more electronegative and due to this it will attract electrons towards itself. This means that, so here you know you have a double bond, so you have a lot of electrons here, lot of electron density. Oxygen will try to attract them towards itself. Now wherever there are more electrons or more electron density, there is a negative charge. Okay, so because of this electron interaction, oxygen will acquire a partial negative charge. Okay, it's not completely taking the electrons, so the charge is only partial, and because of this carbon is losing its electron density and so it is gaining a partial positive charge. Okay, and this arrival of charge in this C double bond O is actually known as dipole-dipole interaction. Okay, you can understand it that this comes from the word pole. Okay, you must have studied this in magnetism. Two poles, north and south, both of them have charge. Okay, so this is where pole comes from. It represents charge. Di means two. So why do we say dipole interaction? We have two kinds of charges forming here. Okay, and because of this charge, we see bonding in aldehydes and ketones as well. For instance, For instance, let's say I have my carbon here in which my oxygen is partial negative, carbon is partial positive charge, and I have my another similar C double bond O. In this one also carbon has partial positive charge, oxygen has slight negative charge. Because of this, there will be an attraction happening in both of these. Okay, so therefore we say dipole-dipole interaction. Okay, so everybody seems to be clear with it. If you have any doubt, you can always let me know in the chat box. Moving ahead, there's a small question for you. I'm going to give you some different compounds and you have to arrange them in the order of increasing boiling points. Okay? Arrange the following compounds in increasing order of their boiling points. Okay, Shillong students, where do you want me to scroll? What have you missed noting down? So students, this is the first part. You have to arrange these compounds in the increasing order of their boiling points. Quickly try to solve this and let me know the answer. The only thing that you have to see here is this kind of bonding which is taking place in all of these compounds, and based on that you will be able to find the correct answer. If you have any doubt, you can let me know. Let's see which center answers this first. Shillong, I assume you want to note this down. Is this what you're talking about? Okay, moving ahead. Okay, Senapati, most of your answer is correct. Just check again once between butanol and diethyl ketone. Think once again about the boiling points of both of these. Okay, students, as we discussed earlier, that in addition to the functional group that you have, you also have to look at the molecular mass or the extent or the length of the chain or the branching that you have in the compound. Okay, so in this case, the hydrocarbon that you have has 5 carbon atoms. However, if you look at your ether, etc., they have lesser number of carbon atoms. So think accordingly. As your length of the chain gets bigger, the boiling point also increases. Okay, Shillong. I think there is some problem in the system. Shillong, are you at least able to listen and see the board? You can just nod as well. Okay, great. Okay, that's great. So I think your chat box is not working. That's fine. I think as long as you're able to understand, it's fine if you don't answer for a while. If you come across any doubt in what I'm saying, you can just raise your hand. Okay, Itanagar, great. But I think Itanagar, you have got the order the other way round. The question asked in the increasing, I think you said in the decreasing, right? But that's fine. Your order is correct. Actually, Itanagar, wait, I think you've got the order of your ether wrong. Your ether is in the wrong position. Just check that again. Okay students, I think a lot of you are confused on this one. So let's just discuss this together and then I'll give you 2 more parts so that you can solve it on your own. Okay, so now first of all, since we have to arrange them in the increasing order, we have to figure out which of them has the lowest boiling point. Okay, aldehyde won't have the lowest boiling point. Similarly, alcohol won't because of strong bonding between them. Now we're left with ether or hydrocarbon. Now, most of the students I think have answered hydrocarbon here, that this has the lowest boiling point, but actually ether is the compound which is going to have lowest boiling point. Okay, and this is because it is a symmetrical ether, and symmetrical ethers have an added stability to them. Now because this stable, their boiling because it's symmetrical, its boiling point would be higher. Okay, sorry, its boiling point will be the lowest. Because symmetry, it will have the lowest or the weakest bonding present in it. This would be followed by the hydrocarbon, and now you have to decide which out of aldehyde or alcohol has the highest boiling point. Okay, between these we've already studied that alcohol is the highest boiling point. So the next compound that we have in our order would be aldehyde, and the one with the highest boiling point would be the alcohol. Okay, is this clear to students? I hope you remember the order for ethers as well. You must have studied in your earlier chapter that ethers have lower boiling point than hydrocarbons because they have lesser bonding, and the type of bond present between them is actually van der Waals forces. And if we have an ether which is symmetrical like this one, then in this case the boiling point is even lower, okay, because the van der Waals forces are even lower. Students, is this clear to everybody? Shillong students, if you have a doubt, please raise your hand. Okay, great. So I think Shillong students have understood. Itanagar students have also understood. Senapati, Temenglong, I hope you're also clear with this. So let us move ahead. Now this question you have to solve on your own, and I hope now I can expect the right answer from all of you. Okay, students, two similar easy questions for you. Arrange them in the increasing order of their boiling points. I hope everybody is on the same page. Tem Long students, I haven't heard from you in a while. I hope you are with us. Okay, Senapati, great, correct answer for the first one. Itanagar also correct answer, but I think you have again arranged them in the decreasing order. Okay, it's fine right now. I understand that you understood the concept, but don't make the same mistake in the exam. When we say decreasing order, that means you have to arrange the compound with the highest boiling point first, which you have done. Okay, increasing order means lowest first, then higher, highest. Okay. So, in the increasing order, your answer would be the other way around. Okay, Shillong, great, correct answer for the first one. So, for the first one, the correct order in the correct increasing order would be okay, most of you have seemed to got this correct. Okay, Senapati, great answer for the second one as well, correct. Shillong, correct answer for the second one as well. Okay, students, so the correct order for this one is, first of all, you have your ether. I'm sorry, I think there's some problem with this page. So the correct order that you have would be the ether that you have. Okay, this is the correct order. Okay, as we studied, this symmetrical ether will have slightly less van der Waals forces in them, so lesser boiling point. Okay, are all of us clear with this? Students, please let me know if you have any doubts till this point, otherwise we will start ahead. Students, any doubt till this point? Shillong students, if you have any doubt, you can raise your hand. Itanagar, Senapati and Temenglong students, any doubt? If there is no doubt, we will move ahead. Okay. So now the next topic that we are going to study is nucleophilic addition reactions. For aldehydes and ketones. Okay, now first of all, does anybody know what is a nucleophile? I assume you must have studied it in your earlier chapters. I think it even comes in class 11th in general organic chemistry. What is a nucleophile? Students, awaiting an answer from you. What is a nucleophile? A nucleophile is a negatively charged species. Okay, I hope all of you remember this. It's the negatively charged species, or you can also say it's electron seeking. Okay, negatively charged species. So now, as we see in the case of aldehydes and ketones, that your oxygen is negatively charged in both the cases and carbon is positively charged, and due to which this carbon is actually the center where a lot of nucleophiles can come and attack. Okay, so this carbon becomes the center for a lot of nucleophiles to come and attack, and therefore we see a lot of nucleophilic addition reactions happening in aldehydes and ketones. So some of these reactions we are going to study today. Okay, now before studying this reaction, let us see the reactivities of aldehydes and ketones. Okay, we saw that both aldehydes and ketones will undergo nucleophilic addition reactions. But now if we have to compare between aldehyde and ketones, which of them do you think would be more reactive towards nucleophilic addition? Okay, great. So aldehydes, correct answer, Itananga students. Aldehydes are actually found out to be more reactive towards nucleophilic addition than ketones, because a ketone has two R groups attached to the carbonyl group. Both of these groups give their electrons to oxygen, because of which it becomes slightly unstable. Okay, it cannot hold a lot of electrons together, so it becomes slightly unstable. But aldehydes are pretty stable even in this partially charged conditions, and therefore they see a lot of nucleophilic addition reactions. The first nucleophilic addition that we are going to see here would be addition of water. When aldehydes and ketones react with water, they form 1,1-diols or gem diols. Sometimes some hydrates are also formed, but these hydrates are actually too unstable, and as soon as they are formed, they get converted into some other product, so we don't get hydrates as a product as such. Now, how does this addition of water takes place? And what is this hydrate actually that is formed? Let's say you have here either this is an aldehyde or a ketone, and you have a water here. Sorry, you have an alcohol here. Now what will happen is this hydrogen will be positively charged, so this will attract the electron cloud over here, and similarly this carbon would be positively charged and this would be negatively charged, So this will attack over here, and therefore the product that you get would be this, which is the hydrate. Okay. Okay, students, any doubt till this point? As you can see that this hydrate actually has two oxygens attached to the same carbon atom. So both of these oxygens will try to attract the electron pairs towards themselves, because of which the carbon gains a lot of positive charge, and therefore the structure is quite unstable. Any doubt till this point, students? Okay, great. Moving ahead, in this reaction only there is actually one more point that we should be discussing, which is steric hindrance. Okay, now steric hindrance is basically what drives this kind of reaction forward. Depending on what kind of ketone or an aldehyde you are starting with, what is the length of its chain, how many branches are there, what is the number of carbon atoms, and so on, we basically find out what will be the product formed in this case. Okay, so let us say, for instance, if I have three groups, I have this hydrate, then I have this hydrate, and I have this hydrate. Okay, can you quickly tell me which of these would be the most stable and which of these would be the most unstable? 1, 2 and 3. Okay, I have given you structures of 3 hydrates based on steric hindrance and electronegativity factors. Can you tell me which of these would be the most stable and which of these would be the least stable? Shillong students, is your chat box working now? Temenglong students, haven't heard from you since quite a while. I hope it's just an internet issue. You're able to understand what we are discussing. Itanagar and Sinapati students, can you quickly tell me the most and the least stable out of these 3 hydrates? The factor that you have to keep in mind is steric hindrance here. Okay, if you have a lot of bulkier groups involved in your reaction, if you have a very long carbon chain or a lot of branching around, then that is what is going to decrease the stability of your compound. Okay, Itanagar, you saying maybe? Why aren't you sure of your answer? So Itanagar, you're actually correct. Okay, 3, if you see, if I have to draw the structure of this compound, it would be like this. If you see, there is a lot of groups combined in a very small space, and therefore this is going to be very unstable. On the other hand, this one it doesn't have bulkier groups, it has very small hydrogen groups attached to it, so it is going to be the most stable. Okay, so 1 is the most stable and 3rd is the least stable. Okay, so correct answer from Itanagar and Shillong on this one. Okay, so now the next addition reaction that we are going to study is addition of HCN. Or hydrogen cyanide. Okay. Now, when any aldehyde or a ketone reacts with hydrogen cyanide, then the product which is formed are known as cyanohydrins. Okay, you should remember this. Cyanohydrins, the term is given to the compound which is formed when any aldehyde or a ketone reacts with hydrogen cyanide. If we use pure HCN here, then the reaction actually takes place very slowly. So, in addition to HCN, we also use some base with it. What happens is, when you have a base, this hydroxide basically comes from the base that you are taking, and you have HCN. The transfer takes place like this. Hydrogen being electropositive will give away the electrons, and this OH will therefore attack here. So this leaves you with cyanide ion and water. Okay, water also, as you know, is pretty stable. So cyanide is going to be left alone while your water is going to be happily formed on the side. Now, this cyanide is what is going to attack on my aldehyde or the ketone. Let us say if I have my aldehyde or ketone, I already know how the electron transfer will take place here. My oxygen would be partially negative, carbon would be partially positive, plus I have cyanide. So now, because my carbon is positive, cyanide will attack over here. And the reaction, now please note here that I am drawing an irreversible, the reversible sign here, because this reaction actually takes place in both the directions. The intermediate that I have would be, first of all, my this carbon atom. I have now, since one electron pair went with O, I will have only one bond left between O, and it will have a negative charge because it has taken electrons. And cyanide has also come and attached with this. So this is the intermediate that I am going to get in this reaction. Now, if I have to get my cyanohydrin from this, I will have to hydrolyze this. I mean I have to give, sorry, not hydrolyze, I will have to give H plus ions here, which can come either from water or HCN as well. Okay, I just need H plus. Why? Because so that this negative charge of O is balanced out. So therefore the product that I am going to get here would be this, and this is what is known as a cyanohydrin. Okay, students. Are we all clear with this? I am going to give you a minute so you can go through it and note it down, and then we are going to see examples based on this. Clear to everybody? Okay, so moving ahead, now let us see some quick examples. Of examples of formation of cyanohydrin. For instance, let us say I have acetaldehyde. And I am reacting with my HCN, and let's say I also have a base with it. Okay, my base will basically provide me hydroxide ions, which are required as we just saw. So in this case, the product that I am going to get would be this, and this is given the name acetyl cyanohydrin. Acetaldehyde, I am sorry. It's formed from acetaldehyde, so the name is acetaldehyde cyanohydrin. Okay, so it's very easy to name cyanohydrins. You basically just take up the name of the starting aldehyde or the ketone that you have, and you just add cyanohydrin after that. Similarly, if I have, let's say, a ketone, okay, I am taking acetone here and I react that with HCN, again in the presence of a base, I get acetone cyanohydrin in this case. Okay, students, so we have discussed examples of both, one aldehyde and one ketone. Quickly note this down, and if you have any doubt, let me know. Okay, students, have you all noted this down? If yes, here are a couple of very small and very easy questions from you. You have to tell me the product formed in these reactions. Okay, students, quickly tell me what product will be formed in this reaction. Are we able to solve this, students? Okay, Senapati, great, correct answer from you. So the product that we're going to get here would be this, okay, and the name for this would be butanone cyanohydrin. You can also call it ethyl methyl ketone cyanohydrin. Both of them are correct answers. Okay, I hope this was clear to you. Shillong students, we haven't heard from you in a while. I hope you're able to understand this and it's only the technical problem in the chat box. Okay, Shillong students, do you have any doubt? If yes, please raise your hands. Okay, great. Itanagar and Senapati students, I hope everything is clear to you as well. So what did we study today? First of all, we discussed some of the physical properties of aldehydes and ketones, in which we discussed their boiling points, their smell and their solubility. Okay, I hope you will now be able to arrange the compounds that you have studied till now, alcohols, ethers, hydrocarbons, etc., in the order of their boiling points as dictated in the question. And also then we studied nucleophilic addition reaction with water and with hydrogen cyanide for aldehydes and ketones. Okay, so if you have any doubt in this, you can always let us know in the WhatsApp group, or you can come to us with your doubt in the next class as well. And so yeah, just solve more problems on this if you can after going home. It should be clear to you, and I will see you in the next class. Bye bye.